In problem 5, we're told that the graph of the axis of symmetry, or we're asked that the graph of the axis of symmetry of the parabola y equals 2x squared minus 11x plus 3 is best described by which of the following equations. So for this particular problem, you need to understand what an axis of symmetry is. And so if I briefly draw a parabola here, the axis of symmetry will be the line that is perpendicular to the x-axis that passes through the vertex of the parabola. So it's a line that passes through the vertex of the parabola but is also perpendicular to the x-axis. So that line in red would be used to represent the axis of symmetry of the parabola. Now obviously you could also have a parabola that's lying on its side. That would be x equals y squared, and then the axis of symmetry would be parallel to the x-axis and not perpendicular to it. But in the general case, it's perpendicular to the x-axis. So all we really need to know, since a vertical line has an equation of x equals something, then all we really need is the x-coordinate of the vertex of that parabola. And I'll show you two ways that you can find the x-coordinate of the vertex of the parabola. Now you may recall that there is a formula that says x equals negative b, not 6, negative b over 2a, and that is the x-coordinate of the vertex of the parabola. So a would be 2, just like in the quadratic formula. A is 2 and b is negative 11. And so we have here that x would be equal to 11 over 4. And 11 over 4 would be equal to 2.75, and so that would be answer D. So that's one way of doing it. Another way that we could have done this, I'll just move that other equation out of the way, is to use our calculator. So using the calculator, we're going to put in the actual equation of the actual quadratic equation or the quadratic function, so that it matches what we're given in the problem, 2x squared minus 11x plus 3. And then we're just going to graph that. And it shows up originally in a way that we can't exactly see where the vertex is there. So I'm going to change my Y window to adjust it to go down instead of where it shows now going from y equals negative 10 to y equals positive 10. I'm going to go from y equals negative 20. And we'll go up to y equals 10 and see what that gives. And so now we can see the vertex of that. And in this case, what we're looking for is a minimum. So I'm going to go over to second calc, and I'm going to look for a minimum. That's option 3. And it asks for the left bound. There could be more than one minimum. So I hit enter there for the left bound. Now I can type in, since I'm at 1, 2, 3, 4, 5, 6, I can say that the right bound would be no more than 6, enter, and then finally for guess, I just hit enter again and it finds it in between there, showing me that the minimum, the x-coordinate of the minimum, which is the vertex of the parabola, is 2.75000008, and because calculators use numerical approximation to do many things, that little 8 way over is really just a byproduct of the numerical estimation or approximation. So the answer is 2.75, and so you could see that also using the calculator as a second way of doing that. So either you remember negative b over 2a, or you can use your calculator to find the x-coordinate of the vertex of the parabola, and you should understand that that gives you the equation of the vertical line then that is perpendicular to the x-axis and passes through that vertex. Okay, so that's it for that problem.